Swayam Prabha. Digital India. Educated India.
Hello everyone. Now we will start our first module, which is blow room. So, in blow room we will start opening and cleaning part. So, if we see the importance of blow room operation, it is a very important operation, it is extremely important. Why? Because about 50% of all shortcomings in yarn is generated from blow room. So, if you see the yarn characteristics, so 50% of them can be controlled by the proper maintenance, proper setting in the proper operation in the blow room. 50% of all quality reducing factors. So, if we see the quality reducing factor like fiber breakage, that is your nape generation. So, all these things are actually generated in the blow room. Improper blow room means we are actually deteriorating the quality basic, that if we damage the fiber in the blow room stage, so that cannot be recovered in the later stage. Around 50% of all yarn break causes like short fibers. So, all these things actually if you see, they are traced either in blow room or in carding. So, if we see in the industry, the causes of breakage, yarn breakage are basically traced back in the. So, blow room is responsible for majority of these faults. So, that is why all above mentioned facts are what makes the blow room very, very important. So, errors or negligence in selecting the composition and treating the raw material in this section can never be actually corrected. So, if we actually select wrong raw material or wrong composition, so that cannot be rectified. So, that is very important, because as it is an important initial stage. Okay. So, subsequent stage is it will actually exaggerate. So, that cannot be rectified. So, if you see the opening action here, there are different processes. Okay. So, at the first process, this is here opening action here. If you see, it is a initial. Okay. So, very low opening. Now, yarn is like process 1, process 2, process 3. If we see up to 3 or 3rd or 4th process, so it gets, we get majority of the opening action here. Okay. Majority of opening action takes place here. After that, if you see, these are almost saturated. Okay. What has reached there. So, further process, here the question is that should we go for the process 6, 7, 8, 9 like that. In this is because we are not achieving any further opening action. So, the first operation requires in the blow room line is opening, which is carried out to the stage of the tuft. So, first opening, because it's we get from the bell and to the stage we get a tuft, small tuft formation. But in the carding process, as I have mentioned, this is blow room, and in the carding process from the tuft we get in the form of individualized fiber. Now, if you see top weight can be reduced to 0.1 milligram, very small top weight we can reduce by proper blow room action, okay? 0.1 milligram at that level. So, you can see the flatter curve at the end shows that the line is far too long. We can have very long line here. So, should we go up to this line? So, we can keep on adding the lines. Here in this fiber, for this blow room line, it should end somewhere at the machine third or fourth. So, we should not go beyond that. What will happen there? If we keep on processing through the different types of beaters, it will unnecessarily actually break the fiber, damage the fiber. So, instead of doing that, what we should do, that in the carding can do the rest of the opening, okay, during individualization. The small improvement by each of the subsequent process. So, here we are getting very insignificant small improvement, okay. By considerable efforts and stressing the material, we are actually damaging the material. We are the fiber gets damaged and unnecessary fiber loss, fiber breakage is there, fiber loss is taking place, and it will be tremendous increase in nappiness of the yarn. So, we should not actually try to improve the openness by further action, okay, beating action. So, as I have mentioned, if necessary, the card can take the rest over action, that it will further open the fibers, okay. And one thing we should remember, the main function of blow room is not the cleaning, okay. Cleaning will automatically be achieved, because when we can open the fibers, the foreign particles or trash entrapped within the fiber mass gets released. The more the opening action, better will be the release, because the impurities can only be eliminated from the surface of the tuft. Like there is a tuft here, impurities will not be removed from the core, it will be removed from the surface, okay. Now, if you see, therefore, it is necessary to create a new surface continuously. Now, it is important, you can see this is a tuft. Here, if you see the trash particles at the surface gets removed from this tuft. Now, in the next process, if you carry the same tuft in this fashion, then the trash particles entrapped inside this tuft will remain there. So, what we have to do? We have to actually create other new surfaces. So, we have to again open it, so the new surfaces are created, and from there again trash particles will come up. So, create new surfaces continuously by opening the material with the progressive line. So, that we can achieve by further opening. So, we are making the tufts smaller and smaller, so that this remaining trash particles gets removed. So, a blowroom installation removes approximately 40 to 70% of the impurity. We should not target the 100%, unnecessarily it will damage the fiber. Rest it will be actually removed by the carding. So, if we try to see for better quality product, we should not target 70% even, we should target say like say 50%. So, that will be enough for the that blowroom process, and next carding can take place, take the load. The result depends on the raw material, the machines and the environmental condition. So, if we see the raw material has got heavy truss. So, that will remove the more particles, and if there is a fine truss particle lower quantity, then the removal efficiency will be less. And environmental condition means if it is dry, the environment is dry, the low humidity, the trash can be removed easily, but if it is the humidity is high, so that will be sticking to the within the structure. Okay. Even the raw material depending on the raw material, so the trash particle removal will also change. So, fiber length, if the fiber length is longer, so trash removal will be difficult. Shorter fiber length or coarser fiber the cleaning will be easier, finer fiber cleaning will be difficult. If you see here, you can see the cleaning efficiency, cleaning index is high when the trash particle is 10%. Cleaning index is low when the trash particle is 5%. So, higher trash percent the cleaning index will be high, because the trash particles are heavier trash particle will get removed easily. If we have say 1% trash in fiber, it will be very difficult. So, in that case we should not target in the blowroom section, the carding can actually remove. So, we should not treat the fiber or should not beat the fiber very intensively. Okay. So, the cleaning effect cannot and should not be same for all impurity levels. It is easier to remove high percentage of dirt. So, it is removed high percentage of dirt from highly contaminated material than from a less contaminated material. That is I have already mentioned. So, increasing the degree of cleaning also increases the negative effect of cotton when they are trying to improve cleaning by intensive operation. That is what I have mentioned, because if we try to clean by intensive operation, so we intensify the beating action, then it will actually create the short fiber loss and also naps. Okay. So, degree of cleaning versus negative effect on cotton. You can see the diagram here. This is this yellow line, it shows the degree of cleaning. So, as the degree of cleaning increases, we try to increase the degree of cleaning, but at the cost of fiber loss. So, if we increase the degree of cleaning, so fiber loss will go on increasing exponentially, then nape generation will be there, it will increase exponentially, it is a very high napes will be there, and also fiber damage. So, fiber loss, fiber damage will be there, surface damage will also be there, which will reduce the tenacity, yarn strength. So, what should we do? Should we go for the lower cleaning efficiency or lower degree of cleaning or higher degree of cleaning? We should not go for higher degree of cleaning, because it will, although it will clean the material, but at the cost of the fiber quality, and also we must need little bit cleaning efficiency. So, that to compromise. So, this is the optimum zone here, and here it is between say 40 to 60 like percent of cleaning, and that also whether to select say 40% or 60%, that depends on the type of fiber. Okay. So, that, and also if it is a longer fiber, we should and finer fiber, we should go for the lower cleaning. Okay. Because in the during the blow room, cleaning action for finer and longer fiber will be difficult. That can be done at the carding or even combing action. Now, it is very important diagram. It is a dust removal at different stages of spinning. Now, here this dark blue color, it is a showing the dust in waste, and here the green color is the dust in the exhaust air. Okay. Dust in waste and dust in exhaust air. Now, here in x axis is the dust removal percent, okay, as a percent of the dust content in the raw material at various processing stages. Now, what are the stages? So, 1 to 5, this is the blow room line, and 6 is the carding. This is the carding, and then it is a draw frame, you can see. Now, here you can see here in dust in the waste, initially the dust in waste is there in the first process, 100% dust is there in the waste, it goes out from there. So, nothing comes in the air, exhaust air in the first blow room line, even second blow room line. If you see in the third blow room line, third beater, third process, here majority is coming through the exhaust air during opening action, it comes to the air, and then here also some portion in the waste dust and majority is in the air, and in fifth line if you see, it is 100% it is going to the exhaust air. So, it is a fine dust. So, fine dust goes in the exhaust air. Okay. And similarly, if you see in the carding, it consists of the, this is the waste, in the card waste it is going, okay, and then majority is going in the fine dust exhaust air. Okay. Here again the filter deposit and liquorine deposits are there. So, A is a filter deposit and B is the liquorine deposit, and similarly in the draw frame also, in the waste we get draw frame waste, if we see we get little bit draft and in the waste and majority in the exhaust air. Okay. So, dust removal is not an easy operation, okay, since the dust particles are completely enclosed within the flocks. So, dust particles, as I have mentioned, it is completely enclosed within the fiber flock, okay, hence are held back during the suction. So, when suction takes place, this dust within the, which are entrapped within the tuft, it's actually, it cannot be removed from the this fibers, and it actually acts as a filter. So, your suction is taking place, but dust is remaining. So, it the fiber tuft acts as a filter, it actually does not allow the fiber. So, what is the what we have to do? We have to actually open it gradually. If we open, then only if you see the fibers, the dust is going into the fine dust particle is going to the exhaust fan. When fine dust the dust particle is going to the exhaust fan, means its opening is there, opening is its ideal case. So, it is mainly the suction unit that removes the dust. So, this is the suction unit removes the dust, but the in the waste whatever it is coming, it is a heavy dust, it comes in the waste, which is shown by the dark blue color. So, dust removal will be more intensive the smaller the tuft. So, smaller the tuft, when the tufts are becoming smaller, dust removal will be there more. It follows that the dust elimination takes place at all stage. If you see, either through the waste or through the exhaust air, but in all the process, even in the ring spinning, the dust removal always takes place. Okay. And you can see this picture shows the dust particle at the surface, dust particle that is removed easily, but which is in the core, it is even through the exhaust fan, it does not get actually removed. Now, coming to the blending. So, blending detailed we will discuss subsequently later, but here basically you can see here the blending of fiber is an essential, and actually it is a preliminary process of the yarn process. So, even if it is 100% cotton, so we need to blend the fibers from different bales. So, it is done at different stages, but it is a preliminary starts from the blow room section. Fibers can be blended at various stages of processes like your blow room, carding, draw frame. So, everywhere we can blend the fiber. However, at the start of the process, one of the most important stages of blending, because if we blend the fiber at the beginning of the process, then we can get the homogeneity in blending. So, to get the homogeneous blended product, we must blend the fiber at the earlier stage, which is in the blow room. So, since the individual components are still separable, so here if you see the fibers here in the individual components are still separable here. Okay. It is available in a separate form and therefore, can be metered. So, we can actually have, we can actually suppose we want to have 50-50 blend. So, here the fiber at the blow room, fibers are available individually, so like polyester cotton or polyester viscose 50-50. So, we can correctly weigh 50-50 blend here. So, that is very important, and we can get the actual blend, but in draw frame and even in carding also, carding that it is a very difficult to maintain the blend percent. So, exactly we can do without depending on the random effect. So, because in the blow room line we can blend the fiber and with a particular blend percent, and randomness will come, because for the subsequent process like carding, draw frame, automatically it will get random. So, well assembled bale layout. So, if we actually assemble the bale layout, this is bale 1, bale 2 bell 3 in this way. If we can arrange the bell in a certain fashion 1, 2, 3, 4 and depending on like this is polyester, cotton in this fashion if we make well. So, there we can get the proper blending. Okay. Now, we can see the so that will be extracted, fiber will be evenly extracted from this bells. So, simultaneous extraction from all bells are taking place, which is used to be normal in conventional process. So, in conventional process what we have to do, we used to do. So, suppose we can take the bell, we can take the fiber from each bell simultaneously like in the stack form. In the stack form like bell 1, 2, 3, 4, 5 and we cut from the at the side. So, we can take the fibers simultaneously in the conventional blending, but in automatic blending it is very difficult. So, there we have different system of blending. So, accordingly intensive blending in a suitable blending machine must be carried out. So, we have to have different blending machine, so that we can get the homogeneous mixing. So, even feed of material to the card, which is important. Finally, the blow room must ensure the raw material is evenly delivered to the card. So, we should not deliver the material in uneven way, like when we are delivering the material like this is suppose polyester, cotton, polyester, cotton, polyester, cotton. So, fibers must be evenly blended, then it is going to the carding machine. But if we do like this, in this portion all polyester, then it is a cotton, in the carding it is very difficult to blend there. Okay. So, that is not required, it is a desirable. So, here it is a, so we have to actually feed the even delivery to the card. Then previously this was carried out using precisely weighing the lap at the scatcher section, but automatic tuft feeding installation are used nowadays. Earlier, so we used to have scatcher section. Now you can see. So here in the lap we used to have proper weighing, but in automatic system where the directly the fiber tufts are coming, automatic tuft feeding. So, there it is very difficult, we cannot do. So, it is important here to blend here at during this stage. Okay. Proper blending should be there. So, while in the introductory phase such installation was subject to problems regarding this. So, here initially this type of in this section we used to have problem in automatic feeding system to get the uniform blending, but nowadays due to the different developments, improvement in the machine parameters, now we can get perfectly even feeding blending. So, now how to estimate the effectiveness of opening and cleaning system. So, intensity of opening, to assess the opening action of a beater, we refer it to a intensity of opening, which is actually termed by the eye. So, intensity, what is intensity of opening? This is the amount of fiber mass in milligram per one strike of the beater. So, for a present production rate and beater speed. So, suppose this is there is a beater, this is the beater spike and the fibers are coming for a certain production rate, fibers are coming here. Now, the amount of fiber, so for one strike how much fiber is being fed. So, that is the intensity of the amount of fiber mass in milligram, how much milligram of fibers are actually presented to the beater per beating, per strike, that is known as the intensity of beating. Now, you can see here the intensity of beating I is actually related with it is a P multiplied by 10 to the power 6, where P is the production rate in kg per hour, I is the intensity of opening, it is termed as milligram per strike, one strike of the beater. So, one strike means number of beaters, this is the beater speed NB and N is the number of strikes. Now, how much strike you are doing giving per actually per unit time or per unit time here per hour. So, per hour how much time strike you are giving. Now, try to see here like P multiplied by 10 to the power 6. So, P is the kg per hour. Okay. So, if we try to convert it to milligram per hour, it becomes the P multiplied by 10 to the power 6, okay, milligram per hour, it is converted to milligram per hour, and if we divide by 60, it is a milligram per minute. So, per minute how much material is being fed to the beater. If we divide by the RPM of the beater, so how much material you are feeding per revolution of the beater, for one revolution how much material you are feeding. Now, if we divide by the number of strikes per revolution, it will become milligram per strike. So, that is how this relationship is evolved. Okay. From there we can calculate the intensity of beating, okay, intensity of opening. So, the intensity of opening is an estimate of tuft size. So, higher the intensity of opening, that means the tuft size will be actually high. Okay. So, from the value of I we can get the approximate number of fibers. So, if we can calculate the number of fibers. So, I is the amount of fiber per strike. So, number of fibers in a particular tuft we can calculate here. So, this is the number of fiber we can, it is related with the LF is the mean average length of fiber in millimeter and TF is the linear density in text of the fiber. So, here we can calculate the number of fibers, okay, in a tuft, smaller tuft, and alternative of tuft size I is the number of blows per kilogram in clay. So, one is the intensity tuft size or this is the intensity, that intensity of opening, okay. We can calculate the number of blows per kilogram. Okay. Earlier I is the per strike, how much amount in milligram was there. Now, here it is a number of blows per kilogram NK. NK is actually we can get NK by 60 N multiplied by N is the N and NB is the RPM of the beater, N is the number of spikes and P is the production. So, we can use production kg per hour. Okay. From there we can calculate the number of blows per kilogram. In 1 kilogram, how much blow we are giving. So, P is the production rate in kg per hour, Nb is the beater RPM and number of strikes per revolution. Okay. So, the I or Nk value indicates the degree of treatment, how much actually beating you are giving. More blows per kilogram of the material, the smaller is the tuft, and more trash is likely to be removed. So, this is the actually these are the intensity of beating, it shows the intensity of beating. However, the calculation does not take account of the space of settings, how much setting is there of the beater and roller. So, in it is very important, this is a beater, this is the beater and here is the feed roller, fiber is coming, is gripping here. Now, how much setting is there, it is not given in this relationship. Okay. And also and of the beater of grid and grid spacing, this is also not given. The mechanical removal of trash and dust particle is always accompanying with the some loss of fiber, fiber loss will also be there. So, usually this is composed of short length broken fiber, that whatever loss of short fibers are broken fiber, but poor processing in the, if you have poor setting and poor setting of grid bar, so long fiber can also be actually removed during the beating action. The objective is to optimize the machine setting, beater speed, production rate, gap between the different components to minimize the percentage of lint loss. Now, the openness is actually calculated by the openness tester. So, more effectively the material is opened, the better is the chance of the fiber cleaning. So, as I have already mentioned, the surface, new surface will come. So, if I see this is the lump of fiber, here trash particles are there. Now, we are trying to open the fiber, same fiber. So, mass m milligram. Now, same fiber we are now opening. M milligram fiber, but the now the it is opened, now trash particles are exposed, the trash particles can be removed or sucked through the air suction, but the what is the difference here? Difference here is the specific volume, okay, specific gravity or it is a openness. So, the more the openness, higher will be the cleaning chances of cleaning. So, that is why we need to measure the openness. Opening as action primarily does two things. One is it reduces the fiber mass into a small clump, okay, and also loosen the tightness of the packing, as I have already shown in this diagram of fiber of each tuft, thereby reducing the tuft density. So, tuft density is reduced or increasing the specific volume, specific volume is increased. Okay. So, that openness value we have to measure. So, how the tuft is being opened, if you want to know, we measure the openness value, okay, and which is it is a degree of opening, it actually shows the degree of opening. Now, how to measure here? So, you can see the sample of fiber, this is a fiber sample, say cotton fiber sample is given here, it is a some Pyrex beater, it is kept, then we are covering with a disc, plexiglass disc, and what we are doing, we are measuring the volume height of this tuft, and from there if we know the cross sectional area, from there we can calculate the, and we know the mass is known. So, from there we can calculate the openness value, okay. And we wait for after putting the load, we wait for to get it settled, and then we calculate the specific volume in cubic centimeter per gram of fiber. So, we do the repeated testing to get mean data with certain confidence limit. So, basically if you see the value of openness value, it is around opening and cleaning. After opening and cleaning a cotton bale, after opening it around 50 cubic centimeter per gram, while at the end of the line it becomes 150. So, in the bale form it becomes 50, and at the, so it increases 3 times, okay. So, at the end that is the optimum value we try to get. Now, if you see here cleaning performance, so it is a feed material here, and then different machine and waste. If you see the waste here is a proper different types of trash particle and output material here we get. This is the after opening we get the that is clean material relatively, but it also contains some trash particle which is subsequently removed in the carding action. Now, cleaning index, if you try to see here, what is cleaning index? So, feed trash percent. So, this is the feed trash percent, we calculate the trash percentage here in the feed material, then we calculate the trash percentage in the output material, then divided by feed trash we get the cleaning index here. We express in another way cleaning efficiency. So, total trash in waste, okay, total trash in waste, this is a total trash M1, and good fiber elimination percent. So, here if we see the how much good fibers are there, so M2 is the good fiber. So, you will see M1 minus M2 by M1 into 100. So, this is the actually M1, this is the percent here, total waste percent, this is the percent. So, from there we can calculate the cleaning efficiency, cleaning index and cleaning efficiency. Cleaning index talks about the overall cleaning of the fiber, and cleaning efficiency it talks about the in the waste percent, in when the waste how much good fibers are being lost. So, degree of opening, degree of cleaning and fiber loss are the primarily actually it is dependent upon and can therefore be influenced by the type of opening machine. So, if we change the, if we have different degree of clean, if we want to change the degree of opening and degree of cleaning, so we actually change the select the opening device, speed we change the speed depending on the requirement, and degree of penetration into the material. So, that means we change the setting here, setting or type of spikes or beaters, type of feed, we will see the how the type of feed affects, spacing of the feed from the opening like setting, type of grid. These are the different factors which affect the degree of opening or degree of cleaning. Area of grid surface. So, higher the grid surface that means better will be the fiber, we can control the fiber loss. Grid setting, airflow through the grid, so that is important. Condition of pre-opening, thickness of the feed web. If the web feed thickness is very high, that means cleaning will be improper. Material throughput. So, higher material throughput will affect the cleaning effect or opening effect. Position of the machine in the machine sequence. So, at what machine sequence we are there, at the initial process we will see the opening action will be more, okay. But as the machines and cleaning action will be more, but as the machine sequence the later stage, the cleaning action will be little bit lower, okay. But their opening will be better. Dirt can be removed partially, okay, practically only from the surface. So, we cannot remove the full dirt, it is partially and from the surface, that I have already mentioned. New surfaces must therefore be created continuously, that is done by the beating action. Otherwise, the dust entrapped within the shaft will remain be there. The form of the opening machine must therefore be adapted to the degree of opening already achieved, okay. So, that means the machine type. So, how much what type of material it is coming, depending on that we have to change the actually the machine. Like I will tell you, in the blow room line, initial machine will be in the coarser beating, but at the towards the end we have fine beating, monocylinder cleaner, and so that it is a very fine spikes should be there, okay. Because if the fibers are already opened, so there we cannot use the same beater again and again, we have to have some finer beating at the later stage. The type and degree of opening device should become continually finer, that I have already mentioned. So, as the process goes, so opening device should be finer and finer. Within the blow room, specific machine is required at different specific position, okay. So, degree of cleaning is linearly dependent upon the degree of opening. So, as we open continuously, the cleaning will increase, because the new surfaces are being created. Newly exposed surface should be as far as possible cleaned immediately. So, whenever we create a new surface, it should be cleaned immediately, otherwise in the next process the same fiber, same trash will get entrapped within the with the adjacent shaft. This means that at each opening step should be followed immediately by cleaning step without intervening transport. So, that means immediately we have to clean, okay, so that the new surface can be re-exposed. Okay. A high degree of opening in the blow room facilitates cleaning in the carding room. That means, we should concentrate on opening at the blow room, cleaning should be the secondary function, okay, in the blow room, because if we can open in the blow room at in a better way, that will help cleaning in the carding. A high degree of opening in the blow room reduces the breakage at the carding. So, if we can open the fiber, so that means that will be fiber in the blow room properly. That means, when it will come to the carding and under the action of the pins, the fiber breakage will be reduced. Aside from economic, therefore, that beside economy, the quality consideration indicates the smallest possible number of machines are there. So, we try to use lower number of beaters, smaller line to reduce the cost. Okay. Even if we keep aside the economy part, but lower line is smaller line is always preferable to actually maintain the quality. So, open flux should approach as closely as possible to the spherical port shape, okay, because then that means if it is spherical, that means there is a cluster is not there. So, otherwise if we that will be the indication of the proper opening. So, narrow flock leads to entanglement during the roller movement. Okay. So, narrow flat flock pneumatic transport finally forms nape. So, it should be spherical shape, and narrow setting of the feed device relative to the roller setting, roller increases the degree of opening, but also it stresses the fiber. So, narrow setting is also not actually preferable, because very narrow setting will increase the degree of opening, but it may break the fiber. So, we have to optimize that. The larger the dart particle, the better is the removal efficiency. It can be finer particle will actually adhere to the surface. Okay. Since almost every blow room machine can shatter particle, as many impurities as possible should be eliminated at the start of the process, because suppose this is the fast blow, here particle sizes are larger, and larger particles are heavier particles that can be actually removed easily at that stage. This is the first stage, but in the second stage, if we see, or second or third stage, we will see these particles are also broken and it becomes smaller particles, and smaller particles has a tendency to stick to the fiber surface due to the higher surface area. So, it will be difficult for the machines to remove this particle. So, at the start of the process, we should try to eliminate the larger as many as possible. Okay. So, in borderline case, there should be slightly less cleaning in the blow room and slightly more at the cart, that I have already mentioned. So, we should always try to reduce the cleaning at the blow room and concentrate on opening action. Where a waste recycling is installed in and is in use, somewhat higher waste percentage can be accepted in the blow room, because waste recycling is there that means in the waste recycling, that means that if in the blow room, if we have higher percentage of waste, that means the some raw good fibers are coming, but waste recycling will recycle this fiber. Okay. So, that is why it is acceptable. Cleaning is made more difficult if the impurity in the dart particle are distributed throughout the large quantity. So, it is basically in the large quantity if it is distributed with the mix in the clean cotton, with the clean cotton. Damp stock, that means higher moisture, as I have mentioned, cannot be cleaned as well as dry particle. So, dry, if it is a moist cotton, it cannot be cleaned easily. Okay. So, thank you. So, we will stop this part here, the opening and cleaning part. So, in next section we will start with a new topic. Till then, thank you.